Welcome back, everyone. Today we will learn about the process control block. Okay, so PCB in short, so it's nothing but a data structure that basically contains the information of the process. Okay, so last class we learned about what a process is and the life cycle of a process. So PCB, just has the information about the process, right? So it says it is also known as the TCB, which is also called as a task control block, and also the entry of the process, okay, table. So it says a PCB contains information about the process, that is the registers, the quantum, as well as the priority. So when we see a process, so basically it has a process state, it has a process number, it has a program counter, it has certain registers and the memory limits, as well as the list of the open files. So whenever we say a process state, so it says in which process, or let's say in which state the process is currently in, whether it's a new state, the ready state, or the running state, or waiting, or the terminated state. So the process state basically tells us in which state the process is currently in. The next thing is the process number. So since we have several processes, every process is given a unique number, or let's say a unique ID to it. So that's nothing but a process number, which is the second part of it. And the next thing is the program counter. So the program counter is nothing but, see, when we say a counter, so it helps us in counting, right? So when we say a program counter, so it says it basically contains the address of the next instruction that basically needs to be executed within the process. And the next thing it has, the PCB basically contains the registers. What are the registers that are required for this particular process? Okay, whether, suppose, let's say you want to do some operation, some mathematical operation, or it could be anything that you would want to do. So there are different kinds of registers. So it basically includes the accumulators, the index register, the stack pointer, and the general purpose registers. And the next thing is the list of open files. So what are the different files that are being associated to a particular process? Because the process does not just mean just one single file. There are many files that are being associated to it. And the next thing is the CPU scheduling information. So basically, every process, along with its ID, it also has a certain priority that has been assigned to a process, and based upon the priority, the CPU is scheduling it. Okay, so we will learn about these scheduling algorithms in the next session. Okay, so here, whenever we say a process, so CPU scheduling information is basically included here. That means the priority of the process, whether, okay, the priority is more or the priority is less, it depends upon, what is the highest priority given to a process. So depending on that, the process will be scheduled in order to run. Okay, and the next thing is the memory management information, like for example, how much data, or let's say how much memory it would require. And when we say memory, it basically talks about data, I would say, which is basically stored within page tables, and we also call them as segment tables. Okay, depending upon how the memory is being divided, okay, and how our operating system is acting like a memory manager for this. So these are some of the things. And the next thing is, yeah, input output status information. For example, what are the input output devices that are being connected to this particular process? Okay, and the next thing is the accounting information. Okay, for example, the time limit, the account number, okay, or I'd say the amount of CPU time that the process uses, okay, in order to execute. And so all of these things are a part of the process control block, or the task control block. So this is what I was trying to tell when I spoke about priority scheduling. So this is what I was trying to tell, that every process, it needs a scheduler, and this is how the operating system works. Okay, now how the CPU is being, basically scheduling it in order to make sure that the processes are being effectively uh, being run within the system. Okay, so there's a particular strategy that basically it follows. So basically there are two categories of scheduling. So one is non-preemptive and preemptive. So whenever we say non-preemptive, so it says here the resource can't be taken from a process until the process completes the execution. That means you cannot, forcefully remove it, or remove a particular process, or let's say you can't forcefully remove a resource from that particular process. For example, okay, let's say you are printing, right? So the printer is connected to the system. You can't forcefully, okay, during the printing process, you can't forcefully remove the printer. Yes, of course you do it, and definitely the process, stops. The printing process stops, right? So preemption, okay, non-preemption is that. Preemptive is just opposite of it. That means you are trying to remove. you're forcefully trying to remove a particular resource, okay, that is being connected to a process, right? So it says for a fixed amount of time. So it says during resource allocation the process switches from the running state to the ready state. That's what I said, okay. This, if you remember this diagram, okay, which I spoke about in my last session, okay, suppose if there is an interrupt, there is an, that's what I said, there's a forceful interrupt that happens, there is an event that has to occur, which is even more important than running this process. So that is when it would go back, okay, to the ready state. So there are different queues here, wherein which it is basically, usually we call them as a ready queue, okay, that basically schedules this, process are being, scheduled. So here there are three different types of queues. So one is a job queue. So it says this keeps all the processes within the system, and the ready queue, the one that is, needs to be executed, okay, next. So this is where, okay, that particular ready queue is basically putting all the processes one, okay, next to each other. And the device queue, so it says the process which are blocked, okay. So for example, due to unavailability of an IO device constraint, let's say due to some power failure or something like that, okay, so it again goes back, such processes are being, uh, put in the device queue and again back to the ready queue when it is ready for execution. So these are different types of, queues, and this is how it would look like if you can see here. So whatever I explained, it's clearly visible through this particular diagram. So basically, there are three types of schedulers. One is long-term, short-term, and the medium-term scheduler. As the name suggests, so whenever we say scheduler, they're basically being brought or being introduced to handle that particular process. Okay, so whenever we say a long-term scheduler, so it says it is also called as a job scheduler, and all the programs, okay, that are admitted. So it says a long-term scheduler determines which programs are admitted to the system for processing and selects only those processes from the queue and loads them into the memory for execution, and the process loads it into the memory for CPU scheduling. So when we say long-term scheduler, so this is where, okay, it's also called as a job scheduler. This is where, okay, it's going to find out, okay, which are the programs, or let's say, I would say not program, I would say a process, because a program and execution is nothing but a process. So better to use this terminology of a process. So um, as it says, like, it is very important that on a long term, okay, for example, okay, it's going to select only those processes that needs to be executed and that it is very sure that it has to be executed. And next thing is the short term scheduler, which is also called as a CPU scheduler. So basically this STS, is basically used to increase system's performance, okay, wherein which it's going to choose a criteria, and it's going to change, or let's say move all the processes from the ready state to the running state. Okay, and the medium term scheduler, which is again a part of the swapping process, like, for example, you're trying to swap the processes in and out. So that's when, okay, the medium term scheduler would help us doing it. And the next thing, that's the context switching. We would be learning this in the next session. Thank you all.